Okay, now we're going to talk about particle systems in Unity. Particle systems are made to simulate smoke and fire and steam and explosions, also magic effects. A particle system is made up of a particle emitter, a particle animator, and a particle renderer. The emitter creates or spawns two-dimensional textures at a given rate and with a given lifespan. So it not only spawns the textures, it destroys them after their lifespan is over. Particle animator animates the color and movement over time, and a particle renderer defines how these particles are rendered in the game, so what the texture looks like. So to create a particle system at its most basic level, you can go to GameObject, create other particle system, and what this does is it creates a game object with three components already attached to it. One is the ellipsoid particle emitter, which emits the 2D particle textures in an ellipsoid bounds, so within a sphere or an oval. The particle animator, which decides how it moves and is colored over time, and a particle renderer, which decides what it looks like as it's rendered. So I'm going to go to the scene view and move my new particle system closer to my camera. I'm going to hit F to zoom in, go back to my perspective view, move it up above the terrain, and you can see it peek into view in the game view. Okay, I'm going to move it a little bit closer to the camera. Okay, so you can see that the particles right now are being emitted in an oval shape. And that's because this is using an ellipsoid particle emitter. So the emit property here determines whether or not the particle system is emitting particles. If you uncheck it, it'll stop emitting particles and it'll let the existing particles die out over time. If you check it again, it'll start to spawn the particles again. The min and max size determine the size of the particles that are being spawned. If the values are the same, that the particles will all be the same size. If they're different, like 0.1 and 0.2, they'll be generated at random sizes between the two ranges. Min and max energy refers to the lifetime of the particles. So this is how many seconds they're going to live for. Right now they're all living for exactly 3 seconds. If you change this to a range, for example, if I change the max to 5, they'll have a lifespan of between 3 and 5 seconds. Min and max emission is how many particles are emitted per second. Right now it's exactly 50 because they're the same. And if I change it, the max emission to 100, then a random value between the two will be generated each time it's emitted. World velocity and local velocity here are the particles' motion at the time of their spawning. So world velocity refers to the absolute global axes, which are defined in this gizmo up here in the corner. So the z is this way, x is always this way, and y is always straight up perpendicular to the ground. So if you change the y velocity to 1, you'll see that the particles have an upward velocity as they're spawned. Now if I change that back to 0, and then change the local velocity of y to 1, it moves in the same direction, and that's because the particle system, the game object here, is aligned to the world object, or is aligned to the world coordinates. If I go into my perspective view in the scene, and then go to my rotate tool, and rotate the object a little bit, you'll see that because the local velocity is set at 1, these particles are moving along the y-axis of the object, like this. And if I change this back to 0, and then change the world velocity of y to 1, they move straight up again in relationship to the global coordinates and the global rotation. So I'm going to set that to 0. Random velocity here, R&D velocity, is a random world velocity that's added to these particles at the time of their spawning. So if you change x to 1, you'll see that the speed of the particles along the x-axis is between -1 and 1 at random values. I'm going to change that back to 0. The emitter velocity scale is the amount of the emitter's speed that the particles themselves inherit. Tangent velocity is the speed along the axes of these particles. So I'm going to change this random velocity back to 0. So whereas world and local velocity, if I change this world velocity y to 1, moves up the y-axis. If I change that back to 0 and then change the tangent velocity of y to 1, this is the movement along the y-axis. So it's creating this this plane of the particles, and you see that it's actually the local y-axis and not the world y-axis. So as you rotate the object, the tangent velocity updates to reflect the local rotation. I'm going to change that back to 0. Simulate in world space means that the particles will stay at the point and speed at which they're emitted, like right now. So if I move this in the scene view, you'll see new particles will get generated where the new particle system game object is, but the old particles stay where they are. Now if you uncheck this, as you move the game object, the particles follow it. I'm going to go ahead and check that again. One shot means that when the emitter spawns for the first time, when this game object awakens, the emitter will emit its min and max emission amount of particles one time, and then it won't emit anymore. So this is for like a water splash or a muzzle flash from a gun or an explosion. Uncheck one shot if you want it to be a constant stream of particles, like some magic effects or a waterfall or a burning fire. Ellipsoid here is the bounds of the ellipsoid that the particles are emitted within. So right now the ellipsoid is 1 meter high, wide, and deep. If I change one of these values, like the z value, to 5, you'll see that the ellipsoid turns into an oval from the sphere it was before. I'm going to change that back to 1. The min-emitter range is the distribution of particles within the sphere. So at 0, they're all distributed evenly within this ellipsoid. If I change it to 1, they're going to be pushed all to the outside of this sphere. And so nothing is going to be spawned in the middle. It's all going to be on the outside bounds of this ellipsoid. And then values in between distribute it at different ratios. Okay, the particle animator determines some properties of how these particles are animated over time, over their lifespan. So right now, the min and max energy I'm going to set so they're both 3. So every particle is going to have a lifespan of 3 seconds. Does animate color determines whether or not the color of the particle is animated over its lifespan. Now that it's checked, I can set what these colors are going to be at different points of their life. So right now, I'm going to have it animate from, let's see, a very pale seafoam color to a dark green. So I'm clicking on each of these 5 palettes here, and then selecting a range of colors that it can transition between. Dark here. Now you can also set the alpha value of each of these particles. So right now the particles start with a low opacity here. This little white and black bar represents that. You can also see it here with the alpha value in these sliders. So they start with a low opacity, then they get strong in the middle, and they fade out again. If this was set instead of 10 all the way up to 255, then they'd start fully opaque. And if this last color was also set from 10 to 255, then they'd end opaque. So right now they kind of flick on and off like Christmas lights rather than fade in and out. But I'm going to go ahead and change those back to 10. Okay. So that's how you animate the color. The world and local rotation axis settings determine how these particles rotate over time, much in the same way that the world and local velocity settings in the emitter determined their initial speed. So right now the particles have a symmetrical texture, so you can't see how they rotate. However, if it was an asymmetrical texture, you could use these rotation settings to tell the particles to rotate over time. But I'm going to set them back to 0 for now. Size grow is the rate at which these particles grow over their lifespan. So right now they're not growing at all. If I change this to 1, you can see that they grow. This is a little more clear when these particles are moving. So if you look here on the random force and force settings, this is the amount of force that's being applied to these every frame versus the velocity up here, which was a constant speed that was applied to these particles as they were created. So if I, in the force settings, give the x force a setting of 1, you'll see these particles move off into the distance, and it's starting to look more like some kind of jet stream or green exhaust flame. Random force is a random value along each of these 3 axes that will be applied to the particles. So I'll set this to 0.5, the y. Actually, I'll set it to 2. And the damping setting in the animator is how much the particles are slowed every frame. So right now at 1, there's no damping at all. They move with a constant force and constant speed. If you lower the value, then they'll slow over time, over their lifespan. And auto-destruct means that the game object that this particle animator component is a part of will destroy itself once all the particles have disappeared. So right now there's always particles being displayed, but if for whatever reason in scripting you told it to stop animating and told the particle emitter to stop emitting, then the particles would eventually die out, and once the last particle disappeared, if auto-destruct was checked, this whole game object would destroy and delete itself from the hierarchy. I'm going to go ahead and check emit again and uncheck auto-destruct. Okay, now the particle renderer has its own settings. Cast and receive shadows determines whether or not the particles will cast shadows onto materials around them or receive shadows from materials around them. This is a Pro-only feature, so checking and unchecking those will affect those settings. Materials determines the appearance of the particles. Right now it's a diffuse particle material. However, if you click on the little arrow here next to element 0, you can select fire add, and these have more of a flamey appearance to them. And if you uncheck actually does animate color in the particle animator component, it'll revert to its initial color, which in your case may be orange and red, although I had changed it to this blue flamey thing here. If you click on Fire Add in the element 0, it'll highlight in the project window, and if you click on that in the project window, then you'll select it here in the inspector. Now what I've done from the default asset is this tint color used to be completely white, so these look like flames. I changed it to a bluish color, so it looks more like a gas jet flame or something like that. If you click back in your particle system, you should see it move again. And if you want to apply more than one material to the particles, you can change the size of this materials array to 2 and choose a different material for the second material here. But I'm going to keep it at 1. The camera velocity scale is how the particles are stretched based on how the camera is moving. Right now they're not being stretched at all because of the stretch particles setting, which I'll talk about right now. Stretch particles determines how they're oriented in relation to the camera. Billboard means that the particles are always going to be facing the camera dead on. So if you look in the scene view, you see that these little boxes around all the particles are perfectly square, and no matter how the camera is rotated around these particles, the two-dimensional textures face the camera. If you set it to, from billboard, find these little arrows, to sorted billboard, the particles get sorted by depth. And this is what you should use if you're blending materials with this materials array here. Stretched means that the particles are going to face the direction they're moving. And if you look in the scene view, you see that they're not facing the camera dead on. They're actually facing, well, right now we have them set here in the animator, that they have a force along the x-axis of 1 and a random force along the y-axis of 2. So these particles are all facing their respective directions right now. If you change the stretch particle setting to horizontal billboard, it means that the particles are going to be aligned not to the camera, but along the XY axes of the world. So this is a flat plane parallel to the ground right now. So this could be maybe like the surface of a lake, or some body of water, or a cauldron. If you change horizontal billboard to vertical billboard, then you get it along the X and Z axes, which is a perpendicular plane to the ground. But again, they're all facing the camera, no matter how the camera is rotated around it. So this is good for a wall or a barrier that you need to pass through. The length scale is how long the particles are stretched in the direction of motion, but that's only if the stretch particle setting is set to stretched. So I'm going to change it to stretched here. Now they're moving in the direction, or they're facing the direction they're moving. Length scale determines how much they're stretched in that direction. So if I change the 2 to a 5, then they get stretched longer in that direction. That's actually pretty sweet. Velocity scale is the rate at which they're being stretched. So if I change this more, they'll be stretched faster. So this to 5, stretch faster. That is actually a really sweet effect right now. I'm really feeling this. And then the last thing in the particle renderer is the UV animation setting. So if you set the stretch particles back to billboard, and I'm going to go up to the particle render and set min and max emission to 1. So it's going to emit 1 particle every second. And right now, if you look at your material, got this little explosion texture. This was created in Photoshop probably. And you see that each particle is made up of the entire texture, just like this. Now, if you change the X and Y tile, what this means is you're telling Unity how many textures exist within your one material. Right now it's just one texture, so this is set to 1. However, if, for example, you wanted to animate it over time, you could have 4 different textures within this. You would subdivide it into 4 sections in Photoshop. So you'd have an upper left texture, an upper right texture, bottom left, and a bottom right texture. They'd all be similar, but they'd be different frames of the same animation. And in that case, you would tell Unity, okay, well, the X tile, there's 2 across, so set that to 2. And the Y tile, there's 2 down, so you set that to 2. And the cycles is how many cycles it goes through over its lifespan. So right now it's going to cycle through once. So if you look in the scene in the game view, you see that each particle over its lifespan cycles between the top left corner, the top right corner, the bottom left corner, and then the bottom right corner, and then it dies. So it's animating a texture that's not meant to be animated, but if you had 4 frames in the texture, you can animate it this way. If you want it to animate faster, you can change the cycles from 1 to, say, 5, and you'll see it animates faster. If you want to fit more frames into the texture, you simply tell it how many more textures there are in this one image file. So if you had a 4x4 grid, you could change this to 4 and 4. And now it's animating through 16 different frames 5 times over the lifespan of each particle. So I'm going to reset that to 1. So in this section, you learned how to create a particle system from the game object menu here, and you learned about the different properties in the ellipsoid particle emitter, in the particle animator, and in the particle renderer. Next, we're going to talk about line renderers.